and welcome to the show. It's me, John Park, and we're here for another John Park's workshop. Thanks for stopping by, everyone. And by everyone, I mean you watching. We've got our chat happening over on YouTube as well as in our Discord. So if you want to come by and talk to some people while you watch, please do so. If you are not familiar with our Discord, it's a great place to chat all the time, but particularly during a live broadcast. And you can find our Discord by heading over to adafruit.it/Discord. You click on a link, you'll get an immediate invite to the Discord server, and then log in, and there you go. And this channel is the live broadcast chat channel. That's what it looks like right there. We got a whole bunch of different channels for discussing different things, different projects, languages, help with PCB design, help with 3D printing. We have general chat, off topic, animal pictures, all that kind of good stuff. So head on over to our Discord and say hi to these good people, including Andy Calloway, C. Grover, Mark Gambler, Gary Z, Dexter Starboard, hello, and Dave Odessa is over there in the YouTube chat, so say hi to him, would you? All right, let's see. What have we got going on? I got a bunch of fun stuff today. I'm excited about this this topic and this show and some of the stuff we'll get to demo and play with today and mess around with things live and possibly make them work better or differently. Before I get into all that, however, I got a couple little things I want to do. First of all, I want to mention we've got our Help Wanted sign up, and that is the job board. If you want to look for work, if you want to try to hire someone, you can head over to jobs.adafruit.com. It looks like this right here. That's the job board, and you can watch a little video describing the job board, welcoming you to it. Thanks, Jesse May, for that. And then take a look at some of the positions that are posted here. There's here's a new one since the last time I checked. It's a microcontroller C++ programmer, custom micro engineering, Hampton, Virginia. Looking for someone to do some remote work. So maybe that's you. Go check it out. We always are vetting all of these, so we don't just throw up any old scam artist on there. No, you can hopefully trust that these are some good jobs with good people. So go check out the jobs board. It's at jobs.adafruit.com. And then next thing I'll mention is we've got, well, I've done this again, have I? Hold on, let me fix this logo that got real tiny. Hey, hold on one second. Why are you so tiny, logo? There you are. I've got a product pick show on Tuesdays. It's JP's product pick of the week. It happens on Tuesdays right at this time, 4 p.m. Eastern, 1 o'clock Pacific time. And it's about a 20-25 minute show. I take a look at a product pick. We have a massive discount on that product just during the live stream. And we even broadcast the live stream from inside the product page. The product this week, actually, let me jump over to that product page for you. That was this one right here. The stereo FM transmitter with RBDS breakout. It's the Scilabs 4713 on a breakout board. And that show I like to take and condense down into a little 1-minute recap to give you a bit of the flavor of the show. So check it out. Me talking to you about this. FM radio breakout.
4, 2, 6, 0.
I've got a little sort of numbers station type of thing playing right now. It's going to play on the initial frequency. After 6 seconds, it's actually going to change itself, and I'm going to tune it down to 90.
Mr. Cunningham
So it started broadcasting.
You must mean the camels
A
in
couple
Egypt.
seconds later, it's going to go out.
Going on.
Now I'm going to retune.
Lands and ocean. Earth's flat.
And there it is again. Oh, not as good a reception there. So you can imagine that you could have this happen programmatically. You could have it changing at random intervals. RDS is how you end up with some info on your usually car stereo display that tells you the artist and song. So that's the product pick of the week. It is the FM transmitter breakout. And you know how you should never throw anything away? I do not have a car stereo other than actually in my car. I used to have one here in a pile of things that I didn't want to discard, but did, and that's too bad because I wanted to hook that up in the shop. I think you just power it off a 12 volt and then play around with that RDS display, which is pretty cool. I do believe you can hook up a software-defined radio and then take a look at that RDS data if you want to on your computer, but nothing quite replaces the experience of seeing it on a little dashboard display, I think. Let's see. So next up, by the way, we're going to get back to that transmitter because that's what I want to work on today for a project. But before we do that, why don't we jump into the CircuitPython Parsec.
CircuitPython Parsec.
All right, let's get this set up. And in fact, I want to bring on this display right here. So this is a terminal. The reason I'm bringing up the terminal and not my coding editor is that what I wanted to talk about today in the CircuitPython Parsec is something called CircUp, which is our CircuitPython updater, or the CircuitPython updater. Entol created this, and we have a page on this that you can check out. So let me jump over to that first, and I'll show you. If you head to let's see, here it is. If you head to the Learn system, you'll see this right here. This is the Learn guide that Melissa did on CircUp. It tells you how to prep your machine for installing, install it using pip or pip3, and then how to use it. So let's get into what it actually is. Let me return to this, this convenient view here. So what this allows you to do is, from this terminal command line, install or update libraries on your CircuitPython device. So I have this little QtPy plugged in right now. It's a QtPy RP2040, and I don't have any libraries on it. In fact, if I head here and list what's on that drive in the library folder, you'll see there's nothing. If I want to, let's say, install the Adafruit debouncer, I like to use that. Rather than going and downloading a zip file with the latest bundle and dragging files over, I can just do this. I can type in circup install Adafruit debouncer. This then goes and grabs the appropriate latest version of the library based on the version of CircuitPython you have installed. You can see it said, found device at volume CircuitPy running CircuitPython 7.0.0 release candidate 2. And then it grabbed the appropriate library and pulled that in. In fact, it even does some things with dependencies. Some libraries require other libraries, and it'll grab those for you if they're not already there. So now if we repeat the directory listing, you'll see I have Adafruit debouncer installed right there. You can also do things like update them. So if you've updated the version of CircuitPython, or there's a newer version of the library, you can do circup update, and it'll go and grab any updated ones. And you can even uninstall from here. So I've done this earlier. I can just grab that command, circup uninstall Adafruit debouncer. It's going to pull that right off, and now when I list the directory, it's gone. The reason I love this is for some devices, particularly memory-constrained ones like a Trinket or a Gemma or a QtPy M0, you don't want to use the Finder or another graphical interface to drag files on, particularly on Mac, because you end up with a bunch of bloated, crufty files on there. And it's a pain in the neck to go and grab things and copy them. This instead sort of does it all for you, not grabbing it locally, but grabbing it off of our GitHub and brings that library right onto the board. And so that is how you can use CircUp to update and install the libraries on your CircuitPython device. And that is your CircuitPython Parsec. Meow.
CircuitPython Parsec.
Hey, there's a terminal. Yeah, how about that CircUp? I see Foamy Guy in the chat, gives it a big heart. I don't really know how to do that. Big heart for the Circup and a little Blinka. Crufty is the word of the day. Yeah, boy, I'll tell you, the it is such a pain in the neck to try to put just the right libraries onto a a memory-constrained device like a QT and realize that just the fact of dragging it with the Finder is adding to the bloat. So I am a big fan of this Circup, and I recommend you check it out. In fact, let me throw that browser window back up there for a second. So here's Melissa's guide on this, and it's a utility written by Nicholas Tollivari, aka Ntol. And if you take a look at the link here, probably goes it goes to Ntol's GitHub, but you can go and check this out on his GitHub repo if you want. Instructions here tell you how to install this for Windows, for Mac, for Linux. Once you get that all prepped and ready, then it'll show you how to use it. So you can do things like freeze the current versions, tell you what version you're running, update, uninstall, as I showed, install. You can even send it to a particular CircuitPy drive. If you have multiple devices on, you can actually specify them using the path flag, or so I've heard. I haven't tried that. I usually just have one CircuitPy device plugged in when I'm trying that. And I will give you a bonus tip. I often rename my drives, and Circup doesn't find them because it's actually just looking for the volume named CircuitPy. So I think I had this one renamed QT RP or something, and it didn't find it. So if you run into an error where it says I can't find any CircuitPython drive, and you know you have one plugged in, watch out for naming there. Yes, we also have more confirmation in the Discord here. First of all, we have this cute llama or something, and then we have another Tobbot says Circup is very good. So many thumbs up on the Circup. Thanks, Ntol. All right. Oh, and here's a bonus tip from Foamy Guy in the chat. Super neat newish feature added by Jeff E. Circup install -- auto will check the code.py file and install any libraries it needs. That's great. I love that. Oh, really cool. I haven't seen that. Thanks for letting me know. I did see the thing, like I mentioned earlier, where it knew that to install one library it needed another, and it threw on like Adafruit Register or Bus.io or one of those. All right, so let's see. Let's get into one other thing I wanted to mention, which is this cute little thing right here. AdaBox. It's coming. It's coming sooner than you think. In about a month, we should be doing the unboxing for this. So I'm not sure. This is probably when the shipping starts, but we give it a little bit of a buffer so that boxes get out there in hands. But right now, we're planning to do the unboxing towards the end of the month of October. So if you are interested in getting an AdaBox 20, I think there may still be some slots left. So don't delay. Go and subscribe, or subscribe and give it to someone as a gift if you already get it yourself and you're excited about sharing. And then if not, if you miss it, then you can get signed up for the one following that, which will be our holiday box. So adabox.com or adafruit.com/adabox to find out more. All right. So yeah, I wanted to get back into this guy. So this is really cool. This little FM transmitter. It allows you to use a microcontroller to control what frequency it's sending on, as well as some other things. But the thing I care about for our project today is the fact that a microcontroller can tell this device which frequency to send on. This device has the FM transmitter built onto it, and it has a 3.5 millimeter stereo input for line level audio. So you can plug any source into it and then broadcast that out to an FM radio. In fact, something I wanted to take a look at here before we move on is a question that I got or a comment that we received after I showed this yesterday. Let me go find, I have a link I want to check out. Let's see if this takes us there. Okay, so the question we get is this illegal? Or the statement we get is, this is illegal. Or we get people saying, watch out, the FCC is going to come and knock on your door. So this is not the case. At least in the United States of America, this device is broadcasting at about, I don't know what the power level it is, but it reaches about 30 feet. And so if you look at the low power radio general information on the FCC, you are exempt from needing a license with Part 15 devices. So this says unlicensed operation of the AM and FM radio broadcast bands is permitted for some extremely low powered devices covered under Part 15 of the FCC's rules. On FM devices, these devices are limited to an effective service range of approximately 200 feet or 61 meters. So this is about 6 times less powerful than that legal limit. So I think we're going to be okay. That's based on a recent Google search while I was eating lunch over to the FCC.gov. And I'm not an expert on it or a lawyer, so consult your local jurisdiction. It could vary by state, municipality, village, township. But as far as I know, we're in the clear transmitting on a low power device like that. And in fact, when you see things like people who have a Christmas lights display and a little sign that says, hey, tune your radio to 98.7 when you get up to the house to watch this display, that's what this is. That's this sort of very low power. It's not interfering with anything, and the FCC is A-OK with it. So let me know in the comments if you have a differing opinion on that, because I'd love to hear it. But as far as I know, we're okay with the low power. All right, so getting into the project, what I wanted to do is a couple things. So I wanted to explore a little further this notion of doing a sort of escape room type of puzzle using the FM broadcaster. And so after building that demo for Tuesday, for the product pick show, I expanded it a little bit. So what you'll see here, let me just show it from the overhead here on my workbench. So what you'll see here, I wanted to describe this and what's going on a little bit because it's nifty. So, oh, I got a light to turn on here. That was looking pretty dark. Turn on a big spotlight. There we go. So what you see here, one, I have my AC on and the fan is blowing the little antenna wire, so you can see that little aerial is moving around there. And then what we've got, in fact, I'll jump over there. Hold on one second. So what we've got here, grab a bright red pointer. This is a Feather RP2040 right here on top. It's plugged into a breadboard, and then it's using I2C to communicate with our transmitter board. And then I have power and ground going to the transmitter board, and there's a reset going to the transmitter board. So the Feather is running CircuitPython, and it is essentially, when it powers up, telling this board the sort of initialization configuration it needs to send out a broadcast of whatever is piped in over this input, this line-in input here. I'm going to zoom in a little bit more. Down here. So you could plug in a radio, a tape player, a phonograph going through a preamp, an MP3 player, whatever you want into here. And this is now going to broadcast it. Initially, I think at 90.3 is what I had. That's the FM station 90.3. And then after a little addition that I did after the show on Tuesday is I added a little toggle switch here. And when I flip that toggle switch, it actually tells the code running on the Feather to switch the frequency, switch the station we're broadcasting on FM from 90.3 up to 103.3, so pretty far away on the dial. And it's almost instantaneous. It just tells this chip, and its chip really quickly starts broadcasting at this new frequency. So that's one side of things, and we'll take a look at the code for that in a moment. But essentially, I've just added this switch and some debouncer code, and then it just has two states that change the frequency. Then what I've got going on from the audio input side of things, this is something we're going to mess around with a little bit in a minute. Right now what I have are three modules that you see here. These are synthesizer modules, generically speaking. Actually, none of these are really a synthesizer, but these are Eurorack modules. And they do three things, three main things. So this one here, this is called, not terribly ironically, this is called radio music. It's from Music Thing Modular. And the idea behind this is actually a sample player. It plays back wave samples or raw audio samples off of an SD card that's plugged in here. And it is meant to mimic the idea of a radio station or a series of radio stations with a series of playlists or songs. So this dial here that changes the stations switches us to different folders of audio files. And this start knob switches us to different wave files or audio files within that folder. And then, actually, sorry, I lied. There's a mode where we can change the station with this knob. Then there's a different mode where we change the song. The start here changes the start point. So where in that song, and it can be really long, it can be an hour-long file if you want, where in that are we going to start when we hit this reset button or we trigger it using this start input here. So this little input, you see that receives a 5-volt ping or a gate signal that tells it to essentially hit that button and restart. We can also use control voltage up to, I think it might be -10 to -5 to +5 to change the station, or maybe it's 0 to 10 volts. And that essentially is turning that knob for us. And then we can hit the reset button. The reset button jumps us, just like hitting this reset. Start changes that control voltage there. So we'll do that. I'll show you that with an audio demo next. And what I'm going to do, just so I can hear a little better, I'm going to turn off that AC. I am going to go ahead and turn on this radio. And let's see if I can. Okay. So you should be able to hear that, and hopefully you can hear me over it. And I'll talk over this for a minute, and then I'll check on the Discord chat if you can still actually hear me, because it's a mix of those two. So I'm going to demonstrate changing the stations.
7, 9, 3, 7. Thank and got 6, 0.
Okay, so I'm going to go check the Discord real quick here to see if you can still hear me. So let me know in the chat if you can hear me and that radio playing. And actually, you know what I'm going to do? I'll pop open the Discord on my phone so that I can see that. That'll make it a little easier to stay over here. There we go. So you can hear, this is a recording of a number station. And I can change to a different. Good. Okay, and so thank you, Jan. C. Grover said that the radio is mixed left, so I panned this one far left. And that'll make sense in a second why I went to that effort. So you can see here, if I hit reset, I can go to the beginning, partway through. Later in the recording. Now, turn that down for a second here. I'll explain a little bit more what's going on the Eurorack side. I have an effects module, a digital signal processing module that allows me to do things like add some delay or reverb. So I'll go ahead and show you that for a second. Okay, so you can see here now I'm adding this kind of cool effect, and I can change some of the parameters. Or bring that back to clean, dry signal. And then lastly, I have an output module, and that's just turning my levels. In fact, I can change the level right there. Why am I not doing it there? So this allows me to adjust the levels. These are at a sort of different gain for Eurorack than what's considered line level, which is more typical consumer audio stuff, and that's what we want to bring in here is a line level signal. So I'm actually going out of the headphone jack of this so that I can control it. Okay, so that's my setup so far. Now, Jan noticed that I had things coming out of the left speaker here. What I'm going to do is I'm going to turn on a second radio. Now, you should be hearing that in the right channel. If you have headphones on, it's easier. And it's playing just something from over the air that happens to be at this 103.3, I think. So now what I'm going to do, let me go to a distinct station on my audio files. And I'm going to switch my output frequency. So now this one's just fuzz. And now this other radio, let me tune that. Uh-oh, have I don't think I'm getting it. Let me hear what that sounds like again. I'm going to switch that.
Degrees.
There we go.
Adam Parker. Temperature is 55 degrees. In the surrounding areas, plain view, cloudy.
There we go. Now switch it again.
Oklahoma City, cloudy. Temperature 54 degrees. Albuquerque,
Okay, so hopefully you can hear that
61 degrees.
moving
Tucson
between
County,
the two
56 degrees. Clovis, cloudy.
sort of
50
stereo
degrees.
sides
City,
there. I'll
sunny.
turn that down right here. And so that's part of my idea with the notion of doing this as a puzzle inside of an escape room, is that you could have different stations playing to different radios. Especially if you're indoors, you may be able to just tune it to fuzz. I didn't pay too much attention, but the best thing would be find a fuzzy spot where you're not actually hearing any outdoor interference, any real station coming in. Tune to that, and that means your radios will either be just kind of white noise, fuzz, or it'll be the station you're sending it to. And that means with just one transmitter, you could have people going around in a space looking to find a part of a clue. Because remember, this is our broadcast station right here. Whatever is on my little SD card there or any other source, this could be a laptop, it doesn't matter. Anything that's able to send a line level audio signal, and it's a stereo audio signal. In fact, I'm just using these essentially as mono, as a mono setup, but you could do this in stereo as well, which also offers opportunity to embed things in different channels for other sort of layers of puzzles upon puzzles, which is kind of cool. And so you have this control of going among stations, and it doesn't have to just be two. You could kind of have as many as you want, depending on what your interface is, or perhaps the entire switching of stations is up to the users. So maybe as they solve puzzles, your microcontroller here, I just have a simple switch, but that could be something with magnets, something with RFID, something with light sensors, color sensors. There's a whole world of possibilities for this. In fact, I made a few years ago a puzzle where if I placed a few chess pieces on the correct spaces, then a drawer opened up with a little solenoid lock. You could do a similar sort of thing, like a chess puzzle that causes radios to play different frequencies in different parts of a space, which I think is really fun, really exciting. Let's see. So what I'm going to do is I'm going to jump to talking about an additional complication on this. So I'm going to turn on my AC again so we don't overheat, or I don't overheat, and my equipment doesn't overheat. And I'm going to check the chat. Let's see. One question we're getting here is, C. Grover says, have you considered mounting the transmitter in its own Eurorack module? Yes, I have. I've been thinking about that for about the last day. It might be a fun Eurorack module to try to design and build that allows you to do a little broadcast, because why not? And I know there are some modules that have, oh, this does not seem, hold on one second, this seems to be in a bad mode. I felt heat coming from my AC, which is just exactly not what I want. There we go, now it's on cold. Oh, that smell when some coils haven't been used as a heater in a while, we got that now, dusty. I know there's some Eurorack modules that pick up radio. I don't know if there's FM. I have seen one for shortwave, but there's probably some that do FM. I think that would be a lot of fun. Let's see. There was a question about, are there open source Eurorack modules? Absolutely there are. There are a couple of great resources. One is, it's not Eurorack format specifically, but Music from Mars. Is that the name of the Music from Outer Space, MFOS? I think it has a Music from Outer Space. There was a book that Make Magazine published that has all of the schematics for building a ton of different synthesizer modules. And then as Todd mentioned, Mutable Instruments is a Eurorack maker who does open source designs, both hardware and software. So those are a great inspiration for people and some of the best modules out there, in my opinion. Oh gosh, someone spotted Laaaaars. That's upsetting. So what I wanted to talk about next is adding to this just a little bit. So we have, as you saw right now, I have control over which frequency I'm sending on the feather. But what about also adding some CircuitPython into the Eurorack system so that I can control the stations or maybe that reset point of the start? And so there are a couple that come to mind. One is the Soul from Winterbloom, and I've shown that on the show before. I don't have it in here with me today, so I'm not going to use that one. But I recommend looking up Winterbloom for amazing modular and some that use CircuitPython. And our good friend Stargirl, Thea Flowers, is the chief genius behind that and does some great work. This one here is something called the Trinket Trigger, and I'm going to show that in the overhead. So you may recognize that lovely little trinket right on top there. That's a Trinket M0, Adafruit Trinket M0 running CircuitPython mounted on some big tall legs there on the top of this module, and you'll see a little @ToddBot there. So this is a module that Todd, our good friend, created, and Todd Kurt, Mr. ToddBot. And what this is a fairly minimal, as you can see, module. It contains a transistor, 2 resistors, a couple of output ports for sending our signal, a button that can be used for multiple purposes, and a couple of capacitive touch pads. And if I plug this in and we take a look at what's running on it right now, you can put different code on here. Let me go to this window right here and see what's running. That should be grabbing that drive. Let's find out. Yeah, nope, that's not it. Hey, what's plugged in? Oh, it's this. I love having a lot of things plugged in. Try again. Python drive, there it is, okay. So Trinket Trigger code, and then the code I'm running right now is a tap tempo. I don't think I'm going to use this. I think I'll use the other one, which is more basic. But this one allows you to essentially set a tempo that can then be a clock trigger. So what I'm going to do is I'm going to open up one I had saved. I'm going to resave this as tap tempo. Does anyone else do this? Save multiple files on one CircuitPython device so you can kind of go back to them later? I do. And now I'm going to resave this one as code.py. It's risky business. You should also be saving elsewhere. But okay, so now when this is plugged into my Eurorack system, it's going to get power and ground over this funky ribbon cable. And then it is going to send out different voltages when I hover over or touch these two capacitive touch pads. I think that's all it's going to do. Yeah. So we're using the two touch, and I can't remember if they're doing anything differently. They might just be set to do the same thing. Todd can remind us, but I think that's what this one does. Mark Gambler says, yes, so many sadly named code1.py, code2.py, and so on. All right, so I'm going to unplug this. And now let's introduce this into the Eurorack system. So we're going to mess around with it a little bit and plug that in, and then we'll be able to rebroadcast our spooky number stations and things over the air to our two different radios. So let me jump over here. And yeah, to whoever asked, I think C. Grover, I definitely, when I took my breadboard and set it right there, I definitely thought, I really should make a module for this. So what I'm going to do is go ahead and unplug that output. I'm going to turn off my modular here. I'm going to find a hex bit to pull off these blind panels. These are blank panels that I use to cover up space that's not populated. And I am going to cross my fingers that I actually have one spare port for power in there. If not, we will unplug the this effects module, DSP module. Looks like I do. Yeah, okay, so I actually had some pre-plugged into there. There's a little power supply in here with some of these ribbons. And what I'll do now is carefully note on this module where it says red stripe, because this is not a shrouded connector, so we just have to make sure we get the negative voltage. These run on positive, what is it, positive 12, negative 12, and 5 for some modules. So hopefully I got that right. Red stripe, kind of triple check that. Set that in here. I'll screw that back down. Why not? Why don't we turn it on once just to make sure? Yeah, okay. That's still working. Screw that down. And, oh, you know what? I left my phone behind with Discord. Let me go grab that. I need to get this iPad back in here that I used to use for reading the chat. That was helpful. There we go. Okay, so we're getting the scoop from Todd. A touch is analog CV out. B touch is an on-off gate. Perfect. That is just what I want. So what we'll do is we'll turn up this radio, plug our output. You running? Let's see, what did I break? I turned the volume down here. Okay. Okay.
Ladies, Thursday night, mostly clear.
Okay.
Lows in the mid-40s. Friday, mostly sunny.
Okay, so now what I'm going to do is take a little patch cable,
Time is 1:50 p.m. Central Daylight Time.
and let's take the B output and plug that into the reset.
Look for the Texas and Oklahoma panhandles.
So now,
Ladies, Thursday, ladies, 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 ladies.
So now every time I press that, it sends a little gate signal, a little kind of square wave, very suddenly, very, very short. I think it's a millisecond or something. Or it might be a little longer. Triggers are shorter. Gates can be held forever. You can hold them for a long time. But when I hit that, it effectively tells that to go back to the beginning. So that's cool. I've got that now. And what I'm going to do next is plug in the output from this A to the station. So what that's going to do is essentially turn this station knob, which is picking the different audio files in that folder, in that sort of larger context. So let's turn this up.
At this time. And now the outlook for days 2.
1, 5, 1.
Thunder. Friday. Thunderstorms are expected across the text.
1, 5. 3.
So this one's capacitive.
7, 1, 5. 3, 9.
So you can hear it's kind of scrubbing through those stations because as I get closer and then touch it, I'm changing the voltage.
3, 0, 0, 0, 1, 1, 3, 3, 6. 1, 1.
So pretty cool, pretty fun. Another thing we can do is just change the start position instead of the station. So let's pick. I like this robot voice.
So that any semblance of my speech will perhaps the echoes of the room reinforce themselves so that any semblance of my speech will perhaps the exception of draw, long cries that draw, oh shit, draw.
So you can see there now I'm able to change where in that sample, in that audio sample I'm picking, and then hit the reset both from here. So that is really cool that we have essentially CircuitPython programmable right on the little Trinket right there. There's no hiding it. You can see what it is. A lot of these modules actually have microcontrollers built into them. A lot of modules are digital. There are also many that are analog circuits, more traditionally. The Music Thing modular radio music here, for example, runs off of a Teensy 3.1 or 3.2 and runs Arduino. I don't know what the Black Hole DSP is running on. It might be a STM32 on there. Pico Out is an analog one, doesn't have any microcontroller. So kind of fun, and you know, obviously this is geared towards Eurorack stuff, this demo, just because I think it's fun. But the cool thing here is that the concept of using another microcontroller to pick your different samples is what really opens this up for things like puzzle solving inside of a escape room type of scenario, a stage type of thing. Or you could set up something that's not puzzling at all, but is instead a controller for you if you're running something like a Halloween haunt and you want to tune in some radios as people walk around, or maybe you want to do motion detection and have a sample go back to the beginning when someone arrives there. Really fun and kind of interesting idea of, instead of wiring a bunch of real speakers up or a bunch of Bluetooth stuff, which is often finicky, this is good old-fashioned FM radio. So you get all the fun artifacts of radio built right into it.
Oklahoma Pass. Day 1, today and tonight. No hazardous weather is expected.
So I'm glad that you stuck around for that. Those of you who did, it's a lot of fun to play with this stuff. And also thanks to my buddy Reggie who lent me a second radio. This little red radio is the only good radio I have left in my life. So he lent me this cool old Panasonic that I think was his dad's. So let's see. Let me jump into any other comments and questions coming from the chat there. Hey, Mark DeVink, I can hear you too. Nice to see you. Thanks for stopping by the YouTube chat. And hey, Randall Bohm, nice to see you as well. Let's see. One question I saw was the source of those samples. Those are a lot of recordings off of BBC and some other places that Tom Whitwell, the person who created that radio music module, collected. And so if you look into the Music Thing modular radio music you will find some documentation on his GitHub. That is also, I believe, open source, right? Yeah, I think that's open source. At least the software is. I'm not sure about the hardware. There's also a bunch of field recordings he made, I think, with a Nagra recorder. But there's a lot of these. There's the Apollo mission audio is on there, and on and on. A bunch of, it's like 8 or 32 gigabytes or something, like 16 gigabytes of these raw audio files. Also a plug for, I always talk about, or I like to talk about when I talk about Eurorack, because it's a pricey hardware thing to dive into. There is a free and open source Eurorack modular software called VCV Rack, and there is that exact module available. So if you want to play with it, you can download the same samples. You just point the hard drive instead of an SD card, but you can use the music thing modular made by Model 80 or something, Mode 80. I forget the name of the company, but there's an authorized group who developed the equivalent as a software module. Let's see. Yeah, Doctor says, Tom Whitwell's page says 4.9 gigabytes for the 8 gigabyte bundle. Yeah, there's a few places to get stuff. Looking around in his on his blog and his GitHub, you'll find it, I think. If you don't, let me know and I'll put it in the chat. Let's see. I'm gonna scroll back a little bit because it looked like some interesting questions. Stargirl is all open source. Okay, I couldn't remember for some reason. I should have guessed. Yeah. Other questions? No. Okay. Well, looks like we're good. Oh, see, Grover says they have 3 seldom used FM radios and 1 SDR here. Yeah, you know, one thing I really like about the using FM and these little samples is that I really like the sound of number stations, but I don't have a shortwave radio, and I think there are still number stations playing, but it's kind of nice to just cut to the chase and listen to them, even if they're not being used by any active operatives. If you're curious about number stations, by the way, there's a podcast I really like to listen to that's called 20,000 Hertz, and it is all about sound. And they did an episode about numbers stations and sort of dove into what they are and how they work, and what we think they were used for, which no one will ever really admit, but has to do with espionage, most of them, and sort of one-time keys, I think, for code ciphers. So I think that's going to do it for today. Thank you all for stopping by. And I will be back on next Tuesday for another John Park's product pick of the week. And I'll be next Thursday on Workshop. And we have a whole bunch of great shows coming up as well. So just check out all of your Adafruit stations to see Scott tomorrow with a deep dive, and Noe and Pedro with the 3 Hangout, and of course Ask an Engineer and Show and Tell, which I believe Noe and Pedro will be hosting next week. I think that's it. We're out of time, so we're not really out of time, but let's call it right there. Thanks everyone for stopping by, and I will see you next time. Bye-bye.
This afternoon, mostly cloudy.
Southwest.